Oh, I'm sorry. Hello, good evening, everyone. Can you hear me?
Yep.
Hi. Welcome to the web talk today.
Hello.
This is day 3 of our web talk on cities and climate, on the series of cities and climate. And today we will discuss the sources of air and water pollution in the context of the pandemic. Cities and climate, which is the overarching topic of the web talk series this week, is also the focus topic of the German Center for Research and Innovation, or the DWIH. My name is Adishri Jamkhedkar. I'm the program manager for the DWIH here in New Delhi, and our team is joining here from New Delhi today. If you are watching us live and want to ask us questions, please use the chat window onto the screen. This is the only way that you will be able to ask us questions. For the participants, the sound, that is the audio and video features, are unfortunately not available. This is only reserved for the speakers and the hosts. But you will be able to ask your questions throughout the session, and we will pick them up for the Q&A session later. All right. We at the German Center for Research and Innovation, we are a group of German research organizations, universities, funding bodies, and research-based companies. We are funded by Germany's Federal Foreign Office and promote German research landscape and enhance scientific exchange and networking between academic communities and stakeholders in science, research, and innovation. To introduce the speakers and take ahead the moderation of the event, I'm going to introduce my colleague and the chairperson of the German Center for Research and Innovation, Dr. Matthias Keithelbach here, who will take over the moderation from here now. Thank you, Matthias, for joining. Thank you so much. The speakers.
Sure, thanks very much. I don't know if you can see me or if you can only see half of me, because I can only see half of me.
Hello, Hello, Sri.
Yeah, I hope this is working for everybody. There is some background noise.
Yeah,
coming through.
Hello.
Hello, Professor Raju. I would suggest that perhaps everybody, apart from me, should mute themselves for the time being until I call on you to deliver your talks.
Hello.
Professor Raju, we can hear you, but it would be good if you mute yourself for now. Thanks very much. So welcome to this web talk, studying the sources of pollution, the corona pandemic as an epistemic opportunity. So my name is Matthias Keithelbach, as you can probably read below my face. I am currently the chairperson of the board of supporters of the DWIH. That is a group of German academic institutions which are active in India. And what we do, both the DWIH as such and our agencies, the individual agencies which we represent, is to try to connect ideas and talent and people from India and from Germany with one another. And this web talk is one example of this endeavor of ours. Before I introduce the three speakers, let me say just a little bit about the seminar. So first of all, it is part of a series on the relationship between the climate and cities. We had the day before yesterday the first seminar on urban mobility. Yesterday we had a seminar on urban flooding, and both these seminars together had about 400 viewers. So this is day 3 of this series, in which we study the sources of air and water pollution and have a particular look at whether the current pandemic helps us in doing this research. So when we first thought about the topic, it actually stood very much in the context of this pandemic. And the thought is, this pandemic is undoubtedly a catastrophe on many fronts and in many respects, but it may also serve as an opportunity for scientists. An epistemic opportunity to study phenomena in a way that we could not study before, or that perhaps that makes it easier to study certain aspects of these phenomena in detail in ways that weren't possible before. So the central question is, are we learning anything new about our areas of study, so sources of pollution, air pollution, particle matter, water pollution, during the pandemic, or perhaps because of it? Now, we put this question to our three eminent speakers today, who have said that they would consider it in their talks, for which I am very thankful. But I should also tell you that we have already been warned by the speakers that in some respects, we simply don't have sufficient data yet that would allow us to address this question in full. Some aspects of changes to air pollution and to water pollution will probably only become researchable, so to speak, at a later point. But at any rate, the speakers will try to address the question, and I'm very much looking forward to this. So we have two experts on water, Professor Nicola Fohrer from the University of Kiel, who is, at least on my view, next to me. Then we have Professor Janardhana Raju, who is joining by mobile phone. So at the moment, his video is a little bit shaky. And we have Professor Mukesh Khare from the IIT Delhi. Welcome to you all, and thank you very much for agreeing to take part in this. I would suggest that we start with air pollution and then move to water pollution. So we would start with Professor Khare from the IIT Delhi and then continue on to the other two experts. What we will do is we will ask each speaker, I hereby ask each speaker to start to give a very short talk between perhaps 10 and 15 minutes or so. And after this, after the three talks have been given, we will have time for a discussion among the speakers and also for questions from the audience. The questions, as Adishri has already said, would have to be typed into the chat that you can see. And the colleagues from DWIH will then pick them up and help me address them to the correct speaker. So if you allow me, I would now introduce, hang on, I was going to introduce Professor Khare, but now I don't see him anymore. Professor Khare seems to have been disconnected, so we will, I think it makes the most sense to change the order for now. I will then let us start with Professor Fohrer, who has already informed us that she will have to leave in time. So we will now change the order. We will start with water pollution and ask Professor Nicola Fohrer from the University of Kiel to start. She heads the Institute of Natural Resource Conservation at the University of Kiel. In her own department is the Department of Hydrology and Water Resources Management. Besides her countless academic publications and projects, and also her work as a reviewer for a number of journals and also for funding agencies, among them, for example, the German Research Foundation, at which I also work. One thing is very noteworthy, namely that Professor Fohrer has a very, very international profile with project partners basically all over the world. She cannot count the times she has been to India, and in fact, we met there, Professor Fohrer, only a couple of months ago, just before the current pandemic in Chennai. So, Professor Fohrer, we are very much looking forward.
Thank you for your kind introduction, and it's really true that I've been to India many times, and it's a pity. I would have really loved to see you in person and to discuss with you in person. as I did at the Waterscape conference a couple of years ago in the German house. So we miss the great hospitality of the German house and the possibilities to chat in the coffee breaks and really interact with each other. Would you like to change again? No, I keep doing the presentation.
Finally, I'm here.
Matthias Keithelbach, do you want us to?
No, but I should just say I just want to welcome now Professor Raju and Professor Khare. We saw that you were disconnected for a moment. I decided to change on the spot the order. I hope that's fine.
All right. Then Adishi, would you please upload my presentation? And I stop my video and I will give my presentation then. Yeah, here we go. A couple of weeks ago, I was invited to join this online discussion on pollution sources and the impact of the pandemic. So I started making phone calls and looking up databases to see what I can present to you today. Yeah, if we think of water, then of course it is present in our life in many aspects. We use it for religious services, we use it for cooking, for drinking water, for creating fish in aquaculture ponds, for irrigation, for industrial production. Nature needs it as a breeding habitat and as also the habitat for fish, for example. We use it for energy production, for transportation, for fishery, for our daily washing. And also for leisure, or it's a cultural heritage as well. So water is present in all of our lives. And without water, we could not exist. And whatever happens, we always will need water. So of course, also in times of pandemic, our concern is to provide clean drinking water and safe water, even if industry had to shut down.
I can see it.
PowerPoint is not visible. I do read
I think
here.
people can.
I can.
I hope this
I'm also seeing. Yes, it is visible.
I can see it too. Okay. All right. Okay. Good. So water is one of the important elements of life. And in Europe, we have a very strong legal framework for water protection. Actually, all European partner countries have agreed to have a joint water policy and to have also a joint water protection legal framework. So also Germany depends on this European framework, and whenever Europe creates a legal framework, then Germany takes it into its national law. One of the important frameworks changes we had in the last 20 years was the European Water Framework Directive. This was the first attempt to unify the legal framework for water quality, and also for a good ecological status, not only of surface water but also of groundwater and coastal water. So this was our first really integrative legal framework we had on European level. Of course, there are also other important European directives, like the Nitrate Directive, that addresses mainly agriculture and the impacts of agriculture on water quality. We do also have other frameworks concerning the use of water. For example, we have a European Bathing Water Directive for lakes and coastal areas where people like to spend their free time for swimming. We do have, of course, a European Drinking Water Directive which sets the standards, the water quality standards of drinking water. Oh, now I can hear an echo. Can somebody mute his microphone, please? And we do have the recent baby in the legal framework is a European Flood Risk Management Directive, which addresses also joint European concepts for flood protection. And within these frameworks, all European member states were obliged to deliver the actual status of water quality. This was also in the year 2000 when this directive was launched. We had 3 years to implement the law in national law, and then in 2004 the first report on water quality had to be delivered to the European Community, and then in 2015 we had a second report to the European Community about water quality in Europe. And of course Germany, as a partner of Europe, had also to deliver its report on national water quality. And I'm going to present you some results or some concerns that we do have with water quality in Europe. If you look at this slide, you see the spatial distribution of the targets of the European Water Framework, and one of the main targets was that we wanted to have a good ecological status in all water bodies, meaning all water bodies, meaning lakes, rivers, groundwater and coastal areas. Besides the ecological status, also the chemical status and the water quantity status was evaluated. What you see in this slide is the percentage of water bodies which will not achieve the good ecological status within the time frame of the European Water Framework Directive. And what you can see, I hope you see also the arrow moving, that also here in Germany we do have a lot of trouble to fulfill the criteria for a good ecological status of water bodies. So water quality, ecological status of waters is a major concern in Europe, but also in Germany. You can see in these lighter blue colors there are areas where we do have more natural water bodies, for example here in Finland, but also here at the Italian islands or in the mainland of Spain, where we do have a reasonable ecological status of water bodies. This is usually due to the missing of agriculture or industrial influences. But if you look at the central part of Europe, you will see that a lot of countries, could you mute your mic please? That we do have considerable water quality problems in Europe. If we look into the individual water bodies, here we see the coastal waters, which we have a data set of more than 2,500 coastal waters were assessed within the European Water Framework assessment. The transitional waters, this means basically the river mouth, the estuaries, the connection of river water to the coast. The lakes, here more than 17,000 lakes were assessed, and the surface rivers, more than 85,000 surface rivers were assessed in ecological status, in water chemistry and also in water quantity. And you see here the colors representing the ecological status of water bodies. If you look at this chart, you can easily see that in rivers and estuaries we are far from our set targets to have a good ecological status. You see that from these 85,000 rivers, more than 60% do not fulfill the target of a good ecological status. The same is true, even worse, for the estuaries. More than 70% of the European estuaries do have a deficit in ecological quality and also in chemical and water quantity problems. The best water bodies are the lakes. Here you have around 50% of the lakes which have a good ecological status or even better, and the other half of the lake is in a bad shape, so measures have to be taken to improve water quality in these water bodies. The data are from 2019, so it's a relatively new data set which has been evaluated based on the results of the first round of the European Water Framework Directive. If you look at the evaluation results in Germany, again we have 4 different water bodies: rivers, lakes, estuaries and coastal waters. You also see only a very small share of green, which represents a good ecological status. So also in Germany, 732 lakes have been assessed, and only 24% of these lakes are in a good ecological status. The majority of lakes is not in a good status. In this assessment, only lakes of larger than 50 hectares have been considered. So all the small water bodies, small rivers, small lakes have been ignored in this assessment. If you look at rivers, the situation is even more grim. Only 6.6% of rivers reach the target, while the remaining rivers face severe ecological problems. The estuaries, the same, it is also very critical. 80% have really only moderately evaluated status, and 20% are really not reaching the targets at all. Same is true for the coastal waters, which are impacted, of course, by nutrients and so on from rivers. They show a relatively bad ecological status all over Germany. What are the reasons, what are the challenges of water quality in this issue? One of the main reasons, of course, is agriculture. Wherever you have agriculture, this is not really an urban topic, but nevertheless also urban areas need provision of food from agricultural areas. So agriculture is one of the main sectors which gives us concerns due to water quality. Then, of course, the wastewater from households and industries, mining waters, shipping, transport via shipping, water power generation and mining. What kind of challenges do they pose to the water bodies? The main concerns from agricultural sites are of course the nutrients, the fertilizers. So whenever the fertilizer leaves the root zone and leaches through the soil and reaches groundwater, which again feeds stream water, you have nitrate transport coming along. Or if you have, as shown here in the picture, soil erosion, then you will have sediment entries and phosphate entries into the surface water, which can create eutrophication. Another matter of concern are pesticides from agricultural areas when they leave the area via water transport or even via wind and are relocated and reach the water bodies. We then have heavy metal pollution from industrial contaminations, for example, or from mining waste. We have micropollutants present in the water, like pharmaceuticals and also in newer days microplastics. And we face a severe destruction of natural habitats by straightening out the rivers or by building weirs or hydropower plants, which disrupts the course of the river and then puts migrating species, for example, in front of large challenges. We are lacking river connectivity due to the same measures, and we do have an increase in water temperature in general, as water is used very often in industry and also in power production as a cooling matter, and the water then leaves the industrial plant much warmer than it has entered the plant. So these are our main concerns in water pollution in Europe and Germany. Now the question or the challenge we were confronted with was to check if we could see any impacts of COVID-19, of the pandemia, on water quality. So what I did is I've basically spent a lot of time on the phone, phoning a German administration, regional and also national, to see if I can get my hands on any water quality data. But the results were very frustrating, because they said, of course, we took the samples already, but currently they are in our labs and they are being analyzed, and you can have information earliest in half a year or so. So I said, okay, this is not the best, this is not an information source. So I started searching for evidence, at least for evidence that there is some change and some impact, which I even can't quantify because data are still not available. of course, and this was pretty obvious everywhere, in India, in China, in wherever you looked, we had a strong decrease in air pollution. So I checked with the ESA, European Space Agency, and they provided satellite images showing the NO2 pollution of the air in comparison from 2019, that's the upper graph, to 2020, to the time of pandemia, and you can see that the pollution is much less. Nevertheless, there is no evidential data for reduced water, for an increase in water quality or for reduced pollution so far. So in this aspect, we know air pollution was decreasing, but we didn't have any evidence for the reduction of pollution of surface water. So I come back to my first slide where I had the different uses of water, and I was thinking, okay, where might COVID have an impact? Industries were shut down, so obviously industrial effluxes were reduced, and the household wastewater and industrial wastewater is treated in wastewater treatment plants in Germany up to 69%. The wastewater treatment plants for sure had a different wastewater signal. So also the wastewater area is somehow affected by COVID-19, and I found some papers stating that they found COVID-19 virus in wastewater and that they used it as an early warning that COVID-19 might be in some area where this wastewater stemmed from. So this was a different an opportunity actually to analyze the wastewater for COVID-19 to see if there was an infection in the area. This, also another important thing which had suffered from pandemia and from lockdown was transportation by ship. And transportation by ship for sure has also an impact on water quality. So I started digging into transportation and these issues. Drinking water is in Germany mainly from groundwater, so there was no impact expected, and also we had drinking water in sufficient quality and quantity available during times of lockdown. I found again remote sensing evidence. Here you see the lagoon of Venice. And you see here, this is the city of Venice. If you ever travel to Europe and you have the chance to see Venice, it's for sure one of the most beautiful European cities, and it interacts very, very closely with water. So you see here the Canale Grande, the big channel through Venice, and there are many, many more small channels. Here you see April 2020. This is the time of lockdown, and this is April 2019, 1 year before lockdown. And if you follow my arrow, you can see all these tiny white dots here. All these are ship. So there is heavy ship traffic here in the lagoon and also on the canal. So the ship traffic obviously was reduced very much in the time of lockdown, because Venice is of course a target of many tourists and also many tourists on cruise ships that visit the city. Oh, the arrow is not visible. That's not good. Okay, there's a green one. Okay. I hope nevertheless, if you look at the lower picture, you see in white there is a, they are the ships. Thank you. Okay, I hurry up. I found one paper analyzing the remote sensing images of Sentinel-2 and calculating the turbidity. So turbidity, of course, is influenced by boat traffic, and it should be reduced if you have less ships. So less sediment is in the water, and you have sunlight going in deeper into the lagoon, which was partly true. So up here you have the pre-COVID and the COVID water quality and of turbidity. But on the other hand, turbidity is also influenced by wind speed. So wind can also mix the surface water and can create turbidity. So the signal was not really clear. Another thing what we have is the ship traffic in Europe. I have here a table from the EMSA 2020 that shows how ship traffic was reduced. This concerns European ships. And mainly cruise ships were completely shut down, so you have a reduction of up to 90% of cruise ships in the lockdown periods, and also passenger ships were reduced significantly. If you look at single ports, the traffic in Hamburg was reduced by 14%, in Barcelona 41% minus, Marseille 39% minus. This means a lot of so less ship in that time. Also, the traffic between EU and China minus 45, China to EU minus 21, EU to US minus 18.5, US to EU minus 35%. So there is an indirect, at least an indirect proof that we have less ship traffic, and obviously probably an impact on sediment balance and thus also turbidity of water. My last slide is another remote sensing image, and here you can see the German Bay. This is the island of Helgoland, and this is the Elbe River with the port of Hamburg. And this is June. The left side is June 2019, the right side is June 2020. And even if you look very closely, you will find very little difference, because the commercial ships are still there and they create still a lot of turbidity and a lot of movement in the water. So it's also not quite clear if we have an impact of COVID-19 here. So to conclude my presentation, we don't have water quality data available yet to assess impacts of COVID-19 and to have hard proof. We do observe indirect effects. We do have less ship traffic. We expect effects from that on turbidity mainly. We do have less air pollution, and we do expect that we will have less deposition on water bodies like the Baltic Sea, for example. So NO2 deposition will probably be less in these times.
Thank you very much, Professor Fohrer. That was a very fascinating talk.
Thank you very much. I'm happy to receive all your questions.
I already have many things I would like to go into detail about. But we first call the other two experts to give their talks. I would say that we now go to Professor Khare, because we wanted to start with Professor Khare at the beginning. Professor Khare is a professor at the Civil Engineering Department at the IIT Delhi. He originally from Varanasi with a PhD from Newcastle in Britain and fellowships in important academic and professional institutions such as the Institution of Engineers India, has more than 150 academic publications to his name, and has managed a large number of environmental projects throughout his career. His academic interests are very wide-ranging. We have invited him to this event because one focus of his is the modeling and also the monitoring of air quality, both outdoor and indoor air quality. Professor Khare, we are very much looking forward to hearing your talk, and you have to tell us if you want to start with the video or the screen directly.
Thank you, Matthias. Can I have my presentation? Is it visible? Slides? Hello?
I see a slide, causes of urban air pollution here.
Okay. So
Yeah, it is okay.
Now that's the beginning.
Yeah, thank you. May I first convey my thanks to DWIH for inviting me to share our experience on air quality during the COVID-19, especially the ambient air quality. So I would be restricting my presentation to Delhi-centric, because whatever the data which we could have from various regulatory agencies within Delhi, it certainly showed quite an enormous effect on air quality. Let's start with the basic, data on the challenges of air pollution. Now, if you see this slide, air pollution is a global problem. That means that if we try to control the air pollution in India within the limit, it doesn't mean that we have solved the problem, because air pollution can travel from Indonesia when they burn the coal, or when they, any other sources. So it may travel to India. So it's a global problem, and that makes us to work together regionally as well as internationally. Second is, it's a problem which is mainly concentrated to the cities. That includes the mega cities, because of the transboundary within the country, transfer of the population from villages to various cities. Especially the mega cities in country like India and China and other developing nations in African continent and Southeast Asia and South Asia, it becomes very critical, because in these cities the development is taking very, very fast. And with this explanation, the WHO has already found a database which says that 97% of cities in low and middle income countries do not meet the air quality guidelines. That shows that how critical the air quality problem is. On the left side, I would like to have the one very alarming, if you can see, it is quite small written over here, that the financial cost on the health risk due to air pollution is quite enormous. It says it's about 5 to 9% of the GDP. So it is quite enormous cost to the health, which is the data which is being taken from the Lancet. So you can see the challenges which air quality is posing to the countries, and especially the developing nations. Now, how these challenges are produced? It means there are some causes for that. Now, I'm gradually converging to the Indian scenario, that is especially towards India-centric, and these causes are not only applicable to Delhi, but most of the cities in India, whether it's a mega cities like Mumbai or Bangalore or Calcutta, or it is growing cities of India. As you know, that we have about 102 growing cities listed by Ministry of Urban Development, where these causes are partially deteriorating the air quality. While in mega cities like Delhi and Mumbai, it has completely deteriorated the environment. What are those causes? We have listed 4 major causes, which we have found for last 21 years, or more than 25 years of working in Delhi and Mumbai and Chennai. These 3 cities we work together as a urban air pollution, group. One is the uncontrolled sources, which are not having a good control, or if they have a control, the monitoring is very poor, so that control is not working. So that is come under the uncontrolled sources. Second is the unaccounted sources. That means that many sources in the developing nation, including India, they are not yet being analyzed properly. Say, for example, the resuspension of road dust, which is a major source in tropical countries like India, and especially the cities where a lot of concreting is going on. So we don't have any emission factors from this resuspension of particles from these pucca or metal roads or metal footpath and grounds. So these are the unaccounted sources. The third is the geographic location, and the fourth is the meteorology. And in meteorology is mainly the wind speed or wind velocity and the wind direction, as well as the humidity and solar radiations, etc. So these are 4 causes which has to be controlled, which has to be analyzed, which has to be studied, and then try to have some, control on that. Now, what are the sources which are accounted into these causes? Now, the sources which causes this air pollution are listed over here in this slide. Now, the sources in red, they are the common for all cities, most of the cities in India. Say, for example, construction dust. Most of the cities in India is experiencing a huge construction industry. A lot of construction is going on, especially the residential, commercial, and all sorts of construction. So these are the common sources in most of the cities or urban areas in India. And the sources which are listed in black, they are the source or city specific. Say, for example, open biomass burning. This is limited or restricted to North India, where the agricultural belt is there. Say, for example, people might be knowing that the burning of the crops in Punjab and Haryana have become, in a certain period of the year, becomes a very important source of PM 2.5 and PM 10 for Delhi. And Delhi experiences enhanced, air quality deterioration during that period. So these are the sources which we have identified by our work, in the air quality, and which causes, increasing air pollution.
Professor Khare, we cannot hear anymore. The sound has gone off. Perhaps I don't know if you did anything, but if you did anything, perhaps you can try to change it.
It is okay.
Now you're back. Okay.
Maybe the internet connection has problem.
Actually, this was Raju speaking, right?
Yeah, that's why I'm talking.
So, Professor Khare, there's still a problem here.
Is it okay? Can you hear me?
Yes, we can.
Hello?
Yes, we can now.
So if you see this pie chart, this is one of the representative status of air quality and sources before lockdown. And this is the area which I have taken is the RK Puram in South Delhi, which is said to be one of the posh areas of Delhi. And I have not taken other pie chart from different areas due to the time problems. Now, if you see this chart, there are three portions which are in gray, yellow, and blue. So these portion tells that how much percentage of sources and air quality in terms of pollution are there. The gray portion tells you, if you can see it, I'm sorry it is quite small written over here, but it is unpaved ground, the gray portion, which is about more than 21%, which deteriorates the air quality. Now, when I say unpaved, it's not that it doesn't mean the road is unpaved, but open grounds. And in South Delhi, there are a lot of open grounds. Parks are there. So that during the summer season, especially, they contribute to the particle pollution. So this is one of the major source in the South Delhi area. Yellow triangle tells you the contribution of air pollution due to cars.
The sound is off again, I'm afraid. We could hear you talk about the yellow triangle representing the cars, and then
Yeah. Oh.
yeah, you are back.
Yeah. So
Yes.
So I continue with that. So this is the status before lockdown, and you can see that what are the sources and which are contributing to the air quality. So next slide shows you, this is the COVID-19 impact on air quality in Delhi. If you see, it is the period which we have worked upon on the data is from 25 March to 14th of April, which is a complete lockdown was there. It's like a curfew-like situation. Now, I'm not showing all the analysis over here because this is the work which we have done and which is under process of publication with Queen Mary University in London. Actually, we compared London lockdown and Delhi lockdown. So, but I'm showing a little bit of extract from this, work. Now, this, slide tells you that we have analyzed, monitoring locations. 3 are urban locations, which is U1, U2, U3. 3 are suburban location, SU1, SU2, SU3. Then road location, R1, R2, R3, the roadside, monitoring stations. And then the last one, is the industrial station. Now, these data have been taken from Delhi Pollution Control Committee because we have around 38 monitoring stations which are all automatic and continuous monitoring stations. Now look, it's very clear from this plot. It's a mean average. It's a mean average of NOx, of PM10 and PM2.5. The blue is the mean average of 2019, while the the orange color tells you the mean average concentration during 2020. Now I'll just take one example of industrial site. That is on the rightmost side. There is a point where you see the NOx. Let me show you the arrow over here so that you can see. This is the point which I am explaining. This is industrial site, which is called it as Anand Vihar, and where a lot of traffic is there. So during the 2019, this was the concentration of NOx. It is more than 120, this. And during the COVID impact, the concentration came down to less than 20. That sort of reduction we observed even in PM10 in different locations, like industrial was more than 120, PM10, sorry, and the during COVID it is less than 20. Same is with the PM2.5. If you see, it is more than 120, and then during COVID it is less than that. So almost all the locations which we have shown in this graph over here, different locations where monitoring station is established by Delhi Pollution Control Committee, reduction was observed. And there is one more publication which was done by Surrey University in London from these data, which I'll show you in the next slide. They also found a similar type of reduction in the air quality during the COVID-19 pandemic. This slide tells you the probability density function of the same locations which we have just described, and it is and this actually tells you that the spread, the blue color tells you the spread, that is the spread, that this how much spread is there right from if you see the 2019 and this is during COVID impact 2020, the spread is so less, reduced a lot, right? So it shows that the sources are all reduced, so spread is also reduced. An enormous decrease, an enormous reduction in all the locations and whether it's a roadside or whether it's a suburban or whether it's urban in PM NOx and PM 2.5 as well as PM 10. I have not shown PM 10 because of the time gap. So we have done this very comprehensive analysis of all over the Delhi, and which is under the process of publication, and it has shown a very, very enormous reduction in the concentration of various pollutants. Now, to summarize all this, the reduction in PM 2.5 during first lockdown, which is complete lockdown, was there. A lot of reduction in PM 2.5. While in this second box, in which in April 2020, a reduction in aerosol loading was observed for Delhi, which is told to be 11 to 29%, and highest was 52%. This data was I have taken from this publication, which is there by University of Surrey, that is the Professor Prashant Kumar, who have done this study, which I'm just putting the arrow over here because very small, this publication, which you can find it out, it is also published. So the same type of similar results that he has also found. So we see in Delhi much stronger decline.
Once again, the sound is off. I would also like to ask you to consider the time, please. Professor Khare, if you can hear us, perhaps you can just type us a signal in the chat, and then we can go on from there. It appears that the connection was completely lost for now. Let me wait about half a minute to see if he comes back, because we had this before once before the session started. If he does not, we will be forced to continue with the next talk, but I think half a minute we should give it, because that was about the time it took last time for him to read. So I'm told by the DWIH colleagues that since we're also running a little bit late, and it doesn't look like Professor Khare is able to come back, I feel bad about this, but we have seen most of the talk, and I think we have got the main message. So I, even though he can't hear me now, I want to thank Professor Khare for a wonderful talk. We can also ask questions afterwards. I think it would now make sense to continue to Professor Raju from the JNU. So Professor N. Janardhana Raju from the Jawaharlal Nehru University. I've actually known Professor Raju for a couple of years now, because he's not only an eminent professor at the JNU, at the School of Environmental Sciences, but also an Alexander von Humboldt Fellow, and indeed the Humboldt Foundation's ambassador scientist in Delhi. And as that, he is also a member of the DWIH family, so we actually get to speak to Professor Raju a lot and learn from him a lot. Professor Raju, with a PhD from Tirupati, has been JNU professor since 2009. Before that, he served at the BHU in Varanasi, also at Tirupati, and also at Asmara University in Eritrea in Africa. Like his colleagues, which you heard just now, his projects also have partners all over the world, including the USA, Brazil, and of course Germany, where he has had his Humboldt Fellowship. One of his latest awards that he received was the National Geosciences Award. So, Professor Raju, also to you, thank you very much for joining us, and I'm looking forward to hearing your talk. Also, you have to tell us if you want to start with the presentation or first the video.
Thank you very much, Dr. Matthias. Thank you very much, Matthias.
Sorry, Raju. We now have Professor Khare back. Professor Khare, how many more slides did you have ahead of you? Because we are also running late. Since you are back now, perhaps it would make sense for you to briefly, yes, please briefly wrap up. Yes, please do. Please do. As brief as you can. I'm afraid I have to ask. Thank you. Go ahead. You can start now. Thank you very, very much, Professor Khare. I'm not sure if you just finished or if the voice is breaking. I see. Who? Thank you very much, Professor Khare. That was great. So we saw more than heard the three conclusions, which were also very much forward-looking, and I think we will talk about them in the Q&A session if we have time for it. Thanks very much. And now I already introduced Professor Raju. I would ask you now to just come, so to speak, come on the digital stage.
Okay, please, Adisri, please upload my presentation. Thank you, Dr. Matthias. Now I'll go ahead with my presentation about water pollution again. Because we heard about water pollution of the lakes and water bodies from Professor Fohrer, and now I will show some river and groundwater pollutions. As said, so first slide please. This is water is very important for our livelihood, and it is elixir of life. And pollution is a human problem. It is a relatively recent development. If you no, this is not this one, not this one. I have sent one presentation, Garima. Is it loading?
Not yet. I only see the Adobe standard screen, share my screen. So perhaps you still have to do it. Now it says upload in progress by Garima. So it should come up in a...
Okay, then I'll give my introduction, okay?
All right.
And because pollution is a human problem, because it is a relatively recent development in the planet's history. Why I'm telling this one? As industrialization has spread around the world last 200 years, and the pollution also spread in rivers or groundwater or whatever it may be. It is mainly, if you can see, water scarcity is mainly due to the over-exploitation of the groundwater and deterioration of the water quality. This is very important. Water pollution and water quality studies are very important in terms of the water scarcity in many parts of the world, especially in India. And another one important is diminishing of the water bodies, lakes and water ponds. People are now occupying and they are using for urbanization or whatever it may be. This also lead to the lot of the environmental issues as well as the pollution issues. And water pollution normally refers to the degradation of the water quality as measured by physical, biological or chemical criteria. This is mainly we can do it in as well as a river or the groundwater things. In my presentations, I will concentrate on sources and types of pollutants and a few examples of the Ganga river and Yamuna where we are working, and also the few Indian examples of groundwater contamination, arsenic pollution and fluoride in a quick way to understand what is the pollutions of surface water as well as the groundwater resources. Mainly in the difference of the groundwater pollution and the surface water pollution, differences in physical, geological, biological environments, the groundwater pollution significantly different from the surface water pollution. This is because you can see the river water pollution, some parameters are very important, ecological parameters, whereas in groundwater the parameters are different. And okay, now it is loading. And in addition to that one, during lockdown, because I will compare some of the data I have procured from the papers and some data collected. During the lockdown, air pollution is drastically reduced when compared to the water pollution in India also, because I have some data I will show. And in Ganga river, examples I will give you Ganga river and as well as the Yamuna river. Next slide, please. Say I will discuss about the sources. Now, if you can see, water pollutants are emitted from the point source and non-point source, because these are very important. How the point source locations are there and non-point. Non-point we cannot see anything, we cannot be traced. But the stormwater runoff will brings all pollutants while flowing or draining. It gets the pollutants to the river. For point source, we can see clearly in specific locations where industrial or factories are there. Because, for example, in India, if you see the Kanpur area, where leather industries are there. They are releasing a lot of chromium contamination in the Ganga plain, where many areas are contaminated, and rectification is taking place. And if you see the water pollution sources and causes, municipal and industrial sources, agriculture sources, and another one is seawater intrusion. One is, if you take the sewer, the leakages in municipal liquid, solid, septic tanks, and roadway dicing is very important in European countries, but we don't have that type of problems here. European countries, they are using salts of roadway dicing in the winter season. That is also creating problem. And industrial liquid tank and mining activities, oil field drains, stockpiles. In agriculture, the field, irrigation return flows, animal waste, fertilizer, these are all non-point sources we can see, but we cannot identify in a point source way. You cannot trace. Seawater intrusion, that is another one in the coastal area, because we have a lot of coastal area in India where over-exploitation brings a lot of pollutants, the seawater intrusion into the coastal, the freshwater coastal aquifers. Next slide, please. Next slide. The source of water pollution, domestic waste, sewage. I want to show some of the, with the pictorial and the diagrammatic way, how pollutants are coming, and aquatic plants and prawn hatcheries. In coastal pollution also we have seen how the coastal pollutions are happening in the, because we worked in recently, we traveled along the coast and we found main hatcheries are going, oil spills are there and solid waste disposals are there. Next slide, please. Then types of water pollutants. Pollutants found in storm runoff, chemical indicators and biological indicators. Because we can see the chemical indicators, sediment and toxic substances, hazardous chemicals, metals, radioactive materials, oil spills, petroleum, thermal pollution, plastics and salts and everything. Because these are all discussed in the previous speaker also. And biological indicators, these are very important in the river and lake, the ecological parameters. Biological BOD, COD, DO, nutrients, and bacteriological pathogens. But if you see the industrial pollution, main problem is creating almost 80%. If you see domestic sewage, 20% of industrial pollution is creating in the world, very problematic. Each year, the world generates perhaps 5 to 10 billion tons of industrial waste, much of which is pumped untreated. But 20%, if you see, it is not much treated, and much of the untreated the effluents are drained into the rivers or oceans or whatever it may be. In addition to that one, atmospheric pollution in smokes, the chimneys, smokestacks and chimneys can enter the atmosphere and fall back again, enter and create problem. But if you see the biological pollution level gets diluted. In some cases, if dilution takes place or the recharge gets the water into the river, but chemical pollution industries destroys the river self-cleaning properties. Next, please. And comes to the polluted contributions of rivers and lakes. If you see rivers and streams and lakes and reservoirs, we can take and main pollutants contribution is pathogens, bacterial, that is the fecal material and all these things, and siltation is the next percentage. Oxygen depleting substances, nutrients. When it comes to the lakes, nutrients are the maximum pollutant, metals and siltation. And right side, the river basin wise, riverine length and different. If you see the all rivers in India, Indian example, if you see here, Ganga river is the longest river lengthwise, and BOD is the 1/3 of the BOD levels are more in the in this river Ganga when compared to others. Others are small rivers. They have also BOD is more than 6 or say 3 to 6. If it is more than 3, it will create problem to the life of the fish or any microorganisms in that area. Next, please. And if you see the relation between BOD and DO, these are all very important parameters in the riverine environment, ecology of this one, health of the river, we can do it. If you see the DO, you start from the normal, the clean zone. When pollution enters, like in, I will show you the Yamuna area, how pollution is creating problem. And it will, when pollutants enters, it decomposition zone starts. And after some time again, because of the mixing and water dilution takes place, and its recovery zone again it starts, and it will give clean while going out. If the same pollution zone in all places, then it will create lot of problem. This happens in our the Ganga river also. In some pockets are highly polluted because of the pollution sources are more. And compared to the another one, BOD and DO, sufficient oxygen is available in the clean zone, and BOD is very less. Decomposition, BOD shoots up and DO less, and like that recovery zone again reverse, inverse. These are all for examples of that one. Next. Next, please. And if you see the nutrients already explained, and if you have a oligotropic lake and eutrophic lake, oligotropic lake is the young lake that only it gradually acquires nutrients and increase slowly. It takes a longer time. Once it becomes eutrophic lake, a biological product causes decaying organic matter here. Here mainly nutrients are responsible for all these things. Eutrophication, and there is a difference between cultural eutrophication. Eutrophication is normally a natural process, but if it is a human activity adds, then we will call it as the eutrophication also increases and quality of the water also coming down. That is called if human activity starts cultural eutrophication. Comes to the average, the phosphates and nitrogen sources. If you see the agriculture activity is a major contributor. When compared to the forest, dead leaves will come. That is only very less, and it will create a less pollution. That is, we'll call it a natural pollutants. When compared to the agriculture and urban area, it creates a lot of nutrients to the river ecosystem or a lake ecosystem. Next. And if an example I will now comes to the Ganga river, here point source and non-point source, it is very clearly given in the chart. In the Ganga basin, approximately 12,000 million liter per day sewage is generated, for which only 4,000 MLD is treated. Remaining, it is going to the river without treatment. It is creating a lot of problems where maximum industrial zones are there, but not entire stretch, because I have shown already Ganga river how the BOD levels are more in 1/4 of the area, remaining is less than 3. That's why wherever the pockets are there, it is creating problem. Point source, you see only industrial waste and municipal sewage. Non-point source, runoff, fertilizers, open-tification, everything, storm runoff will take everything into along with it, and it will join to the river system or lake system, and it will create lot of things. This is the chart for a Ganga river. This is because why they have made this one, because they are using lot of money for the cleaning of the Ganga. Then I will show you how it happened in the lockdown also. Next, please. And COVID-19 lockdown, a ventilator for rivers. Why I am showing this one? Biological indicators during lockdown, March 28 to 2020 in the Ganga river. Monitoring stations, there are 3 upstream side, and DO is 8 and BOD lockdown during the lockdown period. That means river the health is increased, the pollution levels have gone down, and DO is 8 milligram per liter, BOD is also less, and DO in all places if you see around 8 milligram per liter. That means it is very healthy conditions in the river system during the lockdown. The source is CPCB data in March. But I can tell about COVID-19 is gift to Ganga. Why? Namami Ganga project, DO has invested thousands of crores of rupees for cleaning, but failed to achieve the goal. During lockdown, in Haridwar, they reported, in many papers it is reported, it is a fit for drinking. This is unprecedented success. This is due to the less sewage and industrial effluents. And when compared to the ambitious clean river, lockdown has certainly improved the health of the river when compared to only the Ganga cleaning project, not with the other things, not with the air quality or other the parameters. In monitoring stations, Ganga river water found suitable for bathing, propagation of the wild lines in some of the places where monitoring stations were done. Okay, next one. Now, this is a clear example of Ganga river water in Haridwar city. I have seen Haridwar city before lockdown. This is the condition in Haridwar city. And during the lockdown, 15th April, I have taken this photograph published in the website. DO level is around 8 milligram per liter. We are seeing the stones clearly, clear water now. Because of since there is no industrial pollutants and domestic garbage and there is no dip of the pilgrims, everything created because of the lockdown and COVID, this is water is very clean. I have seen this type of thing only 30-40 years back. Now it has come back because of the natural the lockdown conditions. This is the before and during lockdown photographs of both. Next, please. Then comes to the Yamuna River. This is a highly polluted river. Everybody knows who are staying in the Delhi. There are example. Our student has worked and published this paper. There are many points she has collected and she has demarcated different areas. Rural agriculture activity relatively unpolluted in the top. And second one is urban industrial pollution, sewage discharge, mainly Najafgarh drainage the joins here and create lot of pollutant activities, the draining pollution into the river. And the third one is urban agriculture sewage. And again, Indraprastha power plants are there, Rajghat power plant. It is creating ash ponds effluents to the river. And last one is mainly Hindon Canal wastewater, effluent, the effluents from sewage, urban industrial effluents or agriculture are creating the lot of pollution to the river. Because in the lockdown period, because of the pollution is less, that's right. I'll compare it to the next chart. Okay, next please. This is Yamuna River pollution levels comparison 2019 and 20. This is published in the Times of India paper. CPCB, they published this one. They have taken 9 points. They compared Palla to the Okla area. They found there is a increasing of the BOD level in 4 zones only. In left side and right side, if you see 5 zones, 5 points where the water collected and analyzed, the BOD levels are very less. And DO increase to 2.3 to 4.8 milligram per liter, and where in 2019 DO levels are 0 here. But only highest the improvement in 2020 is Paltoon pool, where maybe domestic sewage is entering into the river, where a lot of BOD levels are increasing in 2020 because we are using a lot of water for washing and everything. It is creating more sewage, that is creating also a lot of sewage problem in these areas. And Yamuna River water quality has improved during lockdown compared to 19, but still not met the required water quality criteria. This is very interesting thing. We did not meet the criteria because of the continuous flow of the sewage directly without treatment. Next, please. And I have taken this paper cutting Friday 24th, only the few days back. And again, industry is back because the government has given a free hand for the industries for everything now relaxed. Then the heating water supply again, because in Haryana where industries are there, it is pumping a lot of the ammonia related water or polluted water. Because if ammonia is more than 1 milligram per liter in the water, it may not be used for the treatment thing. That's why again they stopped for 2-3 days for mixing of the dilution of the water, and slowly they are doing, and water supply also affected. In 6th April 2020, water quality has improved during lockdown. 24th, the pollution levels increased due to resuming of the industrial operations. Again back to square one because of the industrial. Because why I am telling this one, industries are mainly creating this when compared to the domestic sewage. It is toxic and it is creating a lot of problem for all purposes. Next one, please. And these are the groundwater pollution. Click again, please. And this is the groundwater pollution where the de-icing and pesticides, and these are all the cartoon I want to show because these are all sources of the groundwater pollution. Next, please. Next. These are mainly human activities. I want to show this one Ganga River where arsenic pollution in groundwater. This is geogenic. Previous slide I have shown human activities mainly created the water pollution cases. In this slide, arsenic pollution, geogenic mainly. This is derived from the Himalayas, and it is mainly West Bengal, Bihar and Varanasi. We worked on Varanasi and we found the arsenic pollution zones. and where it is slowly creeping towards the upstream side. This I want to show this figure. Next one, please. This we worked in Varanasi area where geomorphology controls are very important. Where you see the river meandering responsible for localized deposition of rich sediments in Indo-Gangetic plains derived from Himalayas. Wherever you have a concave side of the river, there arsenic sediments are deposited and releasing because of the presence of the organic rich sediment. Where lack of the reducing conditions, that is organic rich sediments are there, they are arsenic free, but where the organic rich sediments in concave side, where the deposition environmental takes place, there we are getting the releasing of the arsenic into the water, and that's why we are getting pockets in the Indo-Gangetic plain, not in all places of the Ganga plain. This I want to show because how geogenic sources also responsible. This we publish in the High Impact Journal. This one. Next one, please. Next one, please. This is groundwater conditions. I want to show the fluoride contamination. This is also geogenic, not nothing to do with the human activity. Only less amount maybe in fertilizers they are using, but mainly this is starts from in India, Andhra Pradesh, 1937 to till 2000. The people are working, and in all places it is spreading in all states of the India. This is the groundwater fluoride conditions in India. Next, please. Next one. This is the sources of fluoride in the different minerals, how responsible, and these are all the slides we have made it, and how the apatites and bitrates are responsible, and the fluorides are responsible for this. These are all minerals where fluoride content is there. Next, last slide, please. Coronavirus, this is last slide. Coronavirus is the Earth's vaccine. In some, it is true. We are the virus because we are creating. Human beings are creating mainly for the environmental problem, because we can see, we have seen in the corona time where the water is clean now when because of the lockdown period. During the lockdown, domestic sewage would have increased owing to the increased water demand to maintain hand washing hygiene. This is now a little sewage, domestic sewage increased, and there is no industrial effluents, but this domestic sewage has increased. There is an urgent need to reinvestigate the main sources of pollution and reorient river cleaning policies. Next, industrials strictly adhere to the discharge norms. This is not the following in many areas, where I will tell about the Ganga River in Kanpur to Varanasi area through and Allahabad area. This is highly contaminated things because a lot of industries are there. It is mainly Kanpur is one of the best example. It is creating a lot of the river ecological pollutants, water pollution. And install sensor-based real-time water quality monitoring stations along the river. Like air pollution, they are instantaneously they are getting sensor-based data, PM 2.5, PM 10. But in the river system also, we have to have sensor-based real-time water quality monitors in all places. We will get the, along river courses, we will get the real-time data. Then it can be useful for our other purposes also, because how to control, how to treat it and everything. And maintain minimum ecological flows in the river. Because of the many dams have constructed, there is no minimum the ecological flow in many rivers, because we should maintain that one. Then only river pollution diluted, the water pollution diluted, and it can use the some water. Like for example is in Yamuna, whenever less water flow is there, when the pollutants are entered, ammonia levels are increasing, and it is not able to treat the water. In sometimes we have to stop the water treatment plants also. That's why. And to augment the river lake water quality, Inceptor sewage project to trap sewage into the drains. Installation of the treatment plants. This is very important in Ganga plan, cleaning project plan. They are now putting more treatment plants. If treatment is there, then water quality may increase in the river. Mainly, this is the Ganga is our lifeline river in India. Effective surface management. Next, last one, last slide, please. Thank you very much.
Thank you so much, Professor Raju. I love the idea how the coronavirus is the vaccine for the Earth. Let's hope that it forms sufficient antibodies. That will be the question. Will there be enough antibodies? We have had 3 really fascinating talks. I myself have plenty of questions which I would love to ask, but we are short of time and we have to wrap up sometime soon. So I'm very, very afraid that I can only take 2 questions from the chat. One question I have here for Professor Khare and one question I have here for Professor Raju. Professor Raju, if you want to switch your camera on as well, that would be great. Then we can see you. I will start with the question for Professor Khare. That was asked by Krishna Gopal Bhattacharya here, and he says, contrary to your observations, the Assam Pollution Control Board says that there hasn't been appreciable reduction of air pollution at Guwahati during the lockdown. What may be the possible explanation for the same? Is assuming it is true. Do you have an idea? I don't know if I was audible. Professor Khare, there was one question.
I could not hear Matthias because there are some interruptions. Can you repeat it?
Okay.
Can you repeat?
Right, I read it again. Contrary to your observation,
I could not hear the question.
The Assam Pollution Control Board has maintained that there was no real reduction. Sure. Let me try again. In Assam, the Assam Pollution Control Board has said that there has not been a real reduction in air pollution in Guwahati during the lockdown. Is this true? And if so, what could be a possible explanation for that?
Again interrupted.
There is always a bit of a time lag, I think.
Yeah.
Hi, I have a suggestion. Perhaps just go back to your audio, only to the audio function. I think the video is interrupting with.
Perhaps that's the case, yes.
Yeah, sorry for that. Maybe just go back to your audio functions and then we can take the questions there directly. Sorry about that. Let's switch to audio. Professor Raju, only audio. Yeah, same for you, Professor Khare. Let's switch to audio.
Okay.
I don't think it's working now.
Professor Khare, can you just switch back to audio? Yes. Yeah, let's give it a try this way.
So if you can hear us now, there are apparently, according to the Assam Pollution Control Board, there are big differences between cities like Delhi on the one hand and Guwahati, where there has not been any reduction in air pollution. What may be the explanation for that, assuming it's true?
Yeah, that's a good question. I've been to Guwahati, to IIT, and have seen the geographic location of the Guwahati. The geographic location of the Guwahati is quite different than the other cities in India in north and south, because it has a big river catchment, it has a floodplains, and the local sources in Guwahati is mainly the motorized vehicles, and the resuspension of roads, the dust is not as high as you find in other cities of India because of the increased or enhanced humidity over there. So that might be one of the reasons, because our study in Delhi found that local sources are much more responsible for deterioration in air quality rather than the surrounding sources. Now, Guwahati might be having some sources from surrounding areas which are not, reduced. So the Guwahati pollution is remained same during the pandemic. That might be a reason which I can, which I just guess it. I don't know what are the data in Guwahati at the moment, but I would suggest Dr. Bhattacharya that in IIT Guwahati, there is a Professor Sharad Gokhale, who is an air quality specialist. He would be giving much more exact, reasons for this. If it is there, the no reduction is there, he can tell much more about that. Sharad Gokhale is there in the air quality in IIT Guwahati.
Thank you very much. Yeah, that's actually all these things are very interesting for me too, because normally living in Delhi, I'm of course very much interested in where the air pollution comes from, and it will be interesting to see now in the next few months when crop burning resumes, if that also drastically changes the situation again. I have one question here for Professor Raju by Om Prakash Ramalingam Retnam, who says that most of the wastewater treatment plants, they keep the effluent below, I don't know what BOD stands for, but below 20 milligram per liter to be transported to water bodies. But according to your presentation, Professor Raju, the safe limit for aquatics to survive is much lower. It's at 3 milligram per liter. Can you clarify this big mismatch between what the wastewater treatment plants are doing and what you say are the safe limits for effluents flowing into the river?
Okay, that is the treatment plant. That is the generation from the treatment plant. It may be the 20 milligram per liter. But in the river ecosystem, if it is less than 3, only fish and the living organisms may survive. There is a difference between the source and as well as the river system. I am talking about the river. I am not talking about the treatment plant site. There is a difference.
I see. Okay. Right.
In the river system, your river system, it is only DO is higher, more than 4 milligram per liter, and river system, it is less than BOD 3. Then the survival of the fish or living organisms can, the health of the river increases for survival of the living organisms. That is my point. Not from I am not talking about these treatment plants, their standards are 20 milligram per liter. I agree. But once it comes to the river, if it is diluted, then it should come to the less than 3, then only the survival can happen.
I see. Thank you very much. Right. I also found very interesting that in rivers there are these recovery zones. So when effluent is moving into a river at one point, that doesn't mean that necessarily for the entire length of the river water has to be polluted from that point on. So I learned many things. These were just one or two examples today. Thank you very, very much for these fascinating talks to the 3 speakers, only 2 of whom can now hear us. I learned a lot. I'm sure we all did. As I already said, I have many more questions, and I'm sure many other people have many more questions. But what we will do, with your permission, we will be able to publish, I hope, the presentations, and we everybody who has specific questions knows how to get hold of the speakers. The contact details are also on our website. So let me thank you, and I have to do this quickly because time is up and the DWIH team tells me that we really have to wrap up here. So thank you very, very much to the 3 eminent professors. That was great. Thank you also to the DWIH team for managing this. I'm sorry that we ran a little bit over time. That is always the case with these video conferences, in fact, with most in-person conferences as well. Thank you very much also to the audience. We had a very high number. We had over 70 people listening in, asking great questions. And I think this was a very nice talk. I hear that there is now, I see there is a questionnaire put out to the participants. You are now welcome to tell us how this
take
works.
over here.
Okay, thank you very much, Adesha.
Yeah. Thanks again from me as well. Thanks from DWIH. Thanks to Matthias and the speakers and all of you for joining us today. If you could please spare a few seconds and give us some feedback for the session today. Please let us know how you liked it, if you got more knowledge on the topics, and what areas do you think are interesting for research in the Indo-German research, scope of Indo-German research, or otherwise in the post-pandemic situations. We would be happy to hear from you. The survey is now open. It'll stay open for about half a minute. The speakers are also welcome to give us their opinions. That also counts, of course.
What is this back poll? What is this number? Hello, Adisri?
Yes, Professor Raju, this is a feedback poll. It's a feedback.
That means the point 1 to 10 points.
Yes, please read the questions. So there are questions, and then it's a choice answer, and then in one of the questions you are able to write which areas of research could be important. Yes, please.
Okay.
In about 10 seconds, we'll close the poll. So if some of you haven't written your answers, please feel free to do that. We have a couple of more seconds. All right, now we will close the poll. Thank you so much for the feedback. The chat window will stay open for another 5 minutes in case you have feedbacks or questions for us. Please join us over the next events that we would have on the topic over the coming months, and you will hear information from us if you are a part of our database through this event. Please connect with us on our social media, and thank you so much for joining.